Hello, how are you?
Yeah, hi. Yeah, I'm good. How are you? Thank you.
I'm also good. Thank you. So, this call is regarding your interview, and we are going to assess you over Java, Spring Boot, and microservices as specified in your resume. So, could you like to introduce yourself about your background and what technology stack do you use?
Okay, sure. So I have been working in IT since last 4.2 years. So I have experience around 4.2 years working as a Java developer. So when I say Java developer, I know basics of Java, Spring Boot, microservices. I have used Java 8 features in my application or the project. I'm currently working in a domain where it is actually a banking domain, and we are using a microservice based architecture for our application. So when I say microservice based application, so the project flow is like we are designing the UI using Angular, and then the backend has been designed by using microservices architecture. So we have API gateway which acts as a proxy server or front door for our APIs, and then we are using Eureka as a discovery server which will be used to discover the services. And then we have different services like user service, setting service, and all other services to manage the functionality of a particular functional domain.
All right.
And then we are using Hestrix as fault tolerance or Hestrix dashboard to troubleshoot the faults in our application. So this is the basic idea about the architecture.
Great. Sounds good. All right. So, we'll start with Spring Boot. How much do you rate yourself in Spring Boot? Good, average, good, very good.
So I can rate as a good because whatever requirement I'm working on, so I'm able to develop the feature which is required from the application point of view.
All right. All right. So, let's start with Spring Boot. We had Spring, and then came Spring Boot. So, what are the advantages of Spring Boot over Spring? How Spring Boot is better than Spring?
Okay, so there are many advantages of having Spring Boot instead of earlier version of Spring. So the most beneficial advantage is the configuration. So in earlier version of Spring, we were required to configure a lot of things to just get the beans and to just start the application. But that is not the case with Spring Boot. So you can simply use Spring Initializer and configure your Spring Boot application by providing the details like what kind of build you are going to use, what kind of packaging you need, what are the project details like group ID, artifact ID, project description, and which JDK version you are going to use. And you can just include the dependencies which are required for your application and generate the project. And you can use that project and simply run it as a Java application, and your project will be up. So that is one advantage. Other advantage, like in earlier version of Spring, we were required to deploy our application on some server. But in case of Spring Boot, you will get embedded servers like Tomcat server or Jetty server. You can simply deploy your application on that server. Again, like dependency management. So you can use annotation based configuration for your Spring Boot application or managing the dependencies. So these are the few advantages which I can see in a Spring Boot over their version of Spring.
Great, great. Sounds good. So, what is dependency injection? Can you describe dependency injection in Spring and how it helps in managing the bean lifecycle?
Okay, so dependency injection means you are injecting a dependency. Basically, let us consider you are having a class employee, and there are some methods which are there inside the employee, right? So you need an instance of that employee bin. Okay, so you can get the instance of that particular employee bin by dependency injection. So that is, you can call it as a dependency injection. So you are basically injecting a dependency. So there are different ways to inject the dependencies like constructor injection or setter injection. And then the it helps bean lifecycle by decoupling your bean creation and configuration. Okay, so
Okay.
that is one way I can say that it helps to manage the lifecycle of that particular.
All right. Perfect. Sounds good. So, Let's move. What are some of the most common annotations that you use in your Spring Boot application, and what are their
Uh,
purposes?
Okay, so I have used many annotations. Like the very first annotation is that direct Spring Boot application annotation, which we use and main class of our Spring Boot application. So that is a combination of three different annotations, like a direct enable auto configuration, or a direct component scan, or a direct auto configuration annotation. So this a direct component scan basically used to component to scan the components in your application wherever your beans are located or components are located, that will be scanned by this direct component scan annotation. It basically takes one parameter like a base package. So if you mention that base package, it will act as a base package, and whatever components or beans which are available in that, it will scan all those. Then we have REST controller annotation, which is used on your controller layer to route to the APIs to the endpoints. Then you have get mapping, put mapping, post mapping, and delete mapping. These kind of annotations are used to serve the HTTP request like get, put, post, and delete kind of request. Then you can use simply a direct or word annotation to inject the pins. So these are the annotations which I have used in my application. There are many more annotations, but these are the basic annotations which are required.
Great. Sounds good. Okay, so consider this scenario. While serving a request, there is an error. So there is an exception. So how do you handle that exception in your Spring Boot application?
Okay.
Specifically, your global exception handler.
Okay. So you can use a global exception handler class. Means you can create a class which will be exception handler, and you can annotate a direct REST controller advice annotation. So that will be used to handle the exceptions at REST layer. And then you can define a method like handle exception, and inside that method, you can return a response entity, and you can use a direct exception handler annotation for the kind of exception. Let us consider you want an exception like resource not found exception, right? And you can use for that particular exception, you can mention a status code like HTTP status dot not found, right? So you can use a direct exception handler annotation with for the exceptions such as resource not found exception, and you can mention the status code by using HTTP status dot not found, something like that. So you can
Mm,
basically use REST controller annotation, REST controller advice annotation along with a direct exception handler, and define the methods which will take care of those exceptions.
great. Sounds good. Sounds good. Okay. So, what are status code? What are the different status code that you are aware about?
So there are different status codes, like I mentioned 404. It says that the API is not found, or you can say that resource is not found. Then 401 can be used as an authorization, invalid authorization. Then you can use 500 to indicate that there is some issue with the server. Then you can use 403, which indicates that forbidden. Then you can use 200. It indicates that everything is okay. So these are the few status codes which we have used in our application.
Great. Sounds good. All right. So, consider this scenario. I want to design a REST API, and I want to connect to the database, and I want to fetch some data from that database. So, can you briefly explain me how would you do this?
Okay. So first thing
Mm,
is you want to connect with database. So what you need to do is you need to include a dependency related to database, and you can input that dependency inside your form.xml file. And next thing is that you need to provide the database connection related properties like database URL, then username, password, what kind of driver you will use. So all this information can be mentioned inside your application.properties file. Then once you have all this dependency information, then you can go at your Java code, and then there you can design a controller layer, service layer, and then DAO or repository layer. Okay, so that controller will decide, or you can write the endpoints which needs to be executed. So you can write a gate mapping annotation along with a function to get the data from the database. Then from that function, you can give a call to service layer, and from service layer, you can go to DAO or repository layer. So at repository layer, you can perform a simple basic CRUD operations by using JPA repository. So there are many functions which are already provided by JPA repository, and then you can simply invoke the functions. Let us consider you need to get a single record from the database. So in that case, you can use find by ID function, which is provided by JPA repository, and that will give you a result. And then simply take that result and map it with the bin which you want to send as a part of response. So these things will help you to retrieve data from database.
Great. Sounds good. Sounds good. Perfect. So, how do you manage transaction, and at what layer of your Spring Boot application you manage the transaction?
So you can use that direct transactional annotation to manage the transactions, and you can do it at service layer.
All right. All right. And can you tell me briefly what is transaction in your application?
So transaction means, let us consider you are performing some operations related to your data, right? So let us consider you are depositing some money into your bank account. So there must be some code which will be used to deposit that money into your bank account. So we can call it as a transaction. So the code which is associated with that deposit function, we can call it as a transaction.
All right. All right. Got it. So you mentioned you have also worked on microservices. Can you tell me what is microservice?
Microservice, you can say it is a small independent service that is used to perform a specific business function. Okay, so you have a large application and you have different services which will be used to different perform a different business functionalities.
Okay. All right. And what are some of the microservices in your application?
So we have API gateway, that is a single microservice which acts as a front door for our APIs. Then we have discovery service, which is Eureka server. So it is used to discover the services for communication among the microservices. Then we have user service, which acts as which is designed to handle the data related to users. Then we have setting service. So if you are having some settings about your application, then you can write the or handle the settings related functionality inside the settings service. Then we have histories dashboard, which is used to manage the or dashboard is used to display the information about faults in your application. Then we have ELK as a stack, which is used to showcase the logs in your application. Like Elasticsearch is used to log the information about your logs or application details. Then you can use Logstash, which is actually used to log or index the logs to the Elasticsearch. And Kibana is used as a dashboard or console where we can see the information about the logs.
All right. Perfect. So this sounds to be a healthy start. Um, there are two microservices, okay? Microservice 1 and microservice 2. And how do these two microservices communicate with each other?
Okay. So let us consider you need some information from microservice 2. So microservice 1 can call to the microservice 2 by using a REST template. So by using a REST template dot exchange, we can call the endpoint which is available in microservice. Like REST template, we can get the instance of REST template. Then we can use that instance dot exchange method, which basically takes few parameters. The first parameter is like URL or the endpoint which we want to invoke. Then there is a method type. So if you are executing a method which is like get, put, post, or delete, that we need to mention. Then there will be a request entity. Let us consider you need to pass some information as a part of header or as a part of that request. Then you can build a request entity by using that information. And at the last, you will get a response when you invoke that endpoint. So that response needs to be captured somewhere or in some entity or bean. So that will be a fourth parameter. And by using this, you can give a call to the other microservice and get the information.
Great, great.
So that is basically a communication.
Okay. All right. So, can we do this communication differently, using some message broker or something of that sort?
We can use message brokers for passing messages. Like you can use a queue or Apache Kafka, where one microservice will produce the messages into that queue, and the other microservice will consume that queue. So in that case, what will happen? One microservice will continuously produce messages, whereas other will continuously read the messages. So that is another way. Otherwise, you have thin client that can also be used to perform the communication between microservices.
All right, got it. Okay. So, what is asynchronous and synchronous way of communication in microservices?
So synchronous communication means you are performing the operations sequentially. One transaction should be completed before proceeding with another transaction. But in asynchronous communication, you can perform multiple transactions parallel. For this asynchronous communication, the way I mentioned, like you can use queues. So one service will be producing the results and putting it into queue, and the other service will read that queue continuously. So that is a kind of asynchronous communication.
Great. Okay. Okay. So, you mentioned about service discovery. So, what is the flow of service discovery in your application?
Yeah, so service discovery is basically used to discover all the services which are registered with that discovery server. So in our case, we are using Eureka server as a service discovery. So what happens whenever there is a request from UI or client, the request goes through the API gateway, and then that API gateway identifies which service needs to be invoked. So he needs to get the instance of that particular service. So it can check the service discovery whether that instance is available or not. And if that instance is available, you can use that instance and route that request to the particular instance of backend service. So in this way, you can use service discovery to discover the services. So basically, you can use two annotations to make it happen. One is a direct enable Eureka server. That annotation can be used on a class where your service will act as a server, Eureka server, and
Okay.
you can use a direct enable Eureka client to make sure that this service acts as a client and it will be registered with your Eureka server. And that Eureka server URL can be mentioned inside your application.properties file so that it will register with that particular server.
Great, great. All right, all right. So this sounds good. There's something called as circuit breaker. How do you handle fault tolerance in your microservices architecture?
Okay, so circuit breaker pattern can be used to handle the fault tolerance. Let us consider there are two services and one service is calling to other and other is calling to third service A, B, C, or you can consider these three services. So A is calling to B, B is calling to C. But in case C is not responding, so in that case we can use circuit breaker pattern to handle failure of service C. So we can implement a retry mechanism where if the service is down and you are trying to call that service but you are not getting response, so you can try once, twice, third, and then if that service is still not available, then you can send a message that the service is not available, or you can configure timeout settings, something like that. So these things can be used to handle the fault tolerance.
Okay. All right. All right. So, consider this scenario. You have to make a choice between SQL database and no SQL database. So, what kind of data will you store in SQL database, and how do you choose that if you want SQL or no SQL?
So SQL stands for structured query language. So it means that your data should be in a structured manner. Okay, and NoSQL means you can store the data which is not in a structured manner. So we need to decide what kind of data we have. Okay, for example, if your data is in format which is not structured, so if your data is, you are not sure about how many number of columns will be there in your table, so in that case you can go with NoSQL database. So, and in case of SQL, you can have a structured data. So to answer this, I can say that which type of database you have to use for microservices. You need to consider factors like data model, then your consistency requirements. Then you can check your how complex is that database you can say entities, and then based on this you can choose what kind of data you want,
All right. All right.
what kind of structure you want.
Perfect. That sounds good. So, when you deal with database, there is something called as database schema, and with changing requirements, this database schemas change. We need to add column, we need to remove column. And do you know about how do we manage this database schema? Are there any tools?
uh, so you can use tools like Flyway or Liquibase. And apart from these tools, so these tools are basically used to write migration scripts. Okay, so you should have migration scripts which will take care of this database schema changes. So you can even automate this migration script as a part of your continuous integration, continuous development or deployment pipeline. So these tools can be used to manage this changes in your database schema.
All right. All right, perfect. Now, let's come to database part. So what is unique constraint in the database?
So unique constraint basically indicates that the record is unique, or yeah, it is basically applied on a column which will indicate that the value in that column is unique. So any other column, any other record cannot have the same value for that column in your table.
Okay, all right, perfect. Let's discuss about theoretical aspects of Java 8 a bit. So,
Okay.
what is stream in Java 8?
Stream is basically you can call as a pipeline, okay, which will be used to perform or transform the elements of a stream. Let us consider there are some operations which you need to perform. And for to perform those operations, like you want to filter the records. Let us consider there are red, green, and blue colors. We have shapes like circle, rectangle. Okay, and you need to filter the records which you want. Something like you want red color with rectangle shape records. So you can use stream on the list, and then you can use filter function to filter the records which are having red color, and then again you can use same filter function to filter the elements which are having rectangle as a shape.
Okay, all right. So what do you mean by intermediate operations and terminal operation in Java 8?
So as I mentioned, intermediate operations are used to transform the elements of a string, and terminal operations are the operations which will give you the final result, or you can say that it is used to produce the final result from your string. So terminal operations like for each or collect. So these, let us consider you are using a for each operation. So this for each operation performs an action for each element of the string. Collect operation collects the elements of the string into something a list or a kind of collection. Or if you want a count of elements in your string, so in that case you can use count as a terminal operation. And you have intermediate operations which are used to perform intermediate operations or transform the result of elements into a string, like filter, which can be used to filter the results by providing a condition. You can use a distinct to return a string which consists of distinct elements.
Okay, okay, got you. All right. So, which cloud provider do you use to deploy your microservices application?
Sorry, can you please repeat?
Which cloud provider do you use? Do you deploy your application to cloud, or do you have on-premises deployment?
Yeah, actually, this is taken care by our build and release team. They use clouds, but I'm not much aware about it. So we basically provide the our applications jar file, and then they use that jar file generate the Docker images, and by using those Docker images, they deploy the application.
All right,
So I'm
got
not
it.
much sure
Perfect.
about it.
All right, sounds good. So, before we wrap up, let me tell you, we have the application which belongs to finance. So it is finance related application, and the technology stack that we are using is Java, Spring Boot, and microservices. And we are also deploying our application to AWS cloud. So there is a lot of opportunity to learn on those lines. So, do you have any questions for me before we wrap up?
Uh, yeah, I think I don't have any question, but it will be a great opportunity for me if I get selected. I will be able to learn the things which are related to cloud or DevOps related skill sets. So that will add my skill set. That will be
Great.
added in my skill set.
Sounds good. All right. Then I'm done from my side. Someone will get back to you on this.
Okay, so
All right. Thank
yeah,
you.
thank
Bye.
you. Bye.